Hi, in this playlist we're going to be looking at the Edexcel November 2018 Paper 2 Higher Tier. And I'm going to aim to complete this whole paper in roughly about 3 or 4 videos, each lasting about 20-25 minutes or so. Please do stop the video, have a go at each of the questions, compare your solutions. Should give you roughly about an hour's worth of fairly focused revision. Hope it's useful to you. If you're not sure about anything, always add a comment below. I'll always come back to you, and I look forward to seeing you inside the video. Hi, this is the second video in the playlist where we're looking at the November 2018 Higher Tier Paper 2 and its November specification. Okay, so in the previous video we completed through to question number 6. So we're going to start with this one with question number 7 onwards. Please do stop the video, have a go at each of the questions, compare your solutions. Okay, so write the number that in standard form. Well, as you know, standard form means that we need to have the first number between 1 and 9. So I'm going to write this as 8.623. Okay, so the first number has to be between 1 and 9 and then a decimal point. And then basically you want to demonstrate how far the decimal point has moved. So it's actually moved 1, 2, 3, 4, 5 times in that particular direction, which in standard form is the negative direction. So we write that as 10 to the power of -5, and that would be the answer to this particular question. Okay, next question then is going to be, as is a calculator paper, so you can actually put this into a calculator. Just be a little bit careful about how you do it. You might want to use some brackets. You might want to just put those into brackets and those into brackets. It should be okay. To be honest with you, it's been a little while since I actually did this paper, but it might be useful. However, when you finish this, you should end up with something like 7441979.07, and basically that needs to be given correct to 3 significant figures, but also in standard form. So the first thing I'm going to do is make it correct to 3 significant figures. So I'll look at the third one. It's a 4. It doesn't need to change because the number after it is below 5. So 744 stays as it is. But don't forget, I need to make sure that I maintain this place. So therefore I put zeros. Okay, so it would be, what's that, 440,000. Okay, so I now need to turn that into standard form. So like we did before, we want the first number between 1 and 9. So I'm going to put the decimal point here. So it's going to be 7.44, and then I've got to say how many places I've moved the decimal point. Well, I've moved it from here 1, 2, 3, 4, 5, 6 places, but this time in the positive direction. Okay, and that would be the answer to that particular question. Hopefully that's been okay for you. Let's move on then to question number 8, which is a reflection and transformation type question. Okay, so in this one we've got a little bit of work going on first, just to kind of draw the new triangle. So it says triangle P is reflected in the line y equals negative x. Y equals negative x. So we're going to be very careful with that because we want to find out where y equals negative x is. Well, you can kind of either remember it or you could sort of work it out. But effectively, if I have y equals negative x, if I have a value of x is, say, I don't know, 4, then the value of negative x is going to be -4. So in other words, I come along to 4 and go down to -4. Okay, if the value of x is going to be, let's say, -2, then the value of y will actually be +2. Okay, it's the opposite. This negative is going to give you the opposite. Okay, I'll just move that up a little bit so you can see. Okay, all right, so -2 and +2 will be there. So actually the line of y equals -x is going to be this line along here. So if I just kind of draw this in, this is going to be the line that triangle P is reflected in, which is y equals -x. Okay, so the next question is how to reflect triangle P. Okay, well, you've got to imagine that everything is going to hit this mirror line at its perpendicular at 90 degrees. And also you've got to imagine that each of these points, or the shape is made up of 3 separate points. So what I would do is I would say, well, that's one jump across there. So I'm going to go one jump to this side. And then if I look at this point here, now it's a little bit difficult maybe to see on the video, but if you move 1, 2, 3 diagonals, it's going to go 1, 2, 3 diagonals the other side of the mirror line. Okay, and it's the same with this final point over here. It's going to go 1, 2, 3, 4 diagonals. So 1, 2, 3, 4 diagonals. Okay, you need to be very careful with these. I would say reflections are not as popular as they used to be, but certainly I do come across them. Rotations, reflections, translations, all that sort of thing. Okay, so it is well worthwhile kind of practicing it. Of course, if you go to 3-Minute Maths, you can download a worksheet and have a look at that. Okay, so it's to give triangle Q, and there it is. Okay, then it says triangle Q is now reflecting the line x equals -1 to give triangle R. Okay, so well, again, we've got to find the value or the line where x equals -1. Well, basically, it's any value where x is -1, or rather any coordinate, so -1, 3, or -1, -3. So -1, 3 is here, and -1, -3 is here. So actually the line of y equals -1 is going to be this line here. Okay, actually I'll just put a straight line down there. Okay, and that is going to be x equals -1. Okay, I'm sorry about my hand being in the way so much. Okay, so what we're going to do is we're going to reflect Q in that particular line. So again, as we've done before, we want perpendicular. We've got 2 jumps here. I'm going to run 2 jumps the other side. Okay, 2 jumps here, 2 jumps the other side. Okay, remember that it's not the x-axis, the y-axis rather, it's the line x equals -1. So 1, 2, 3, 4. And then 1, 2, 3, 4. Okay, so what we end up then is triangle R, which is going to be this one here. Okay, and there it is. And this is going to be now triangle R. Okay, then it says describe fully the single transformation that maps R to triangle P. Okay, so a little bit tricky. There's a couple of ways of doing this. Ordinarily, I would maybe use a little bit of tracing paper, which you can ask the invigilator for. However, in this particular case, what I can recognize is that it's a 90-degree rotation. And what I do know is if you can imagine this point here, it's rotated 90 degrees to this point here. Okay, and it's actually rotated around this point. Okay, so actually I do know with this particular one, and you could check it with the others as well. If you rotate along 4 and up 2, you're going to go down 4 and along 2. Okay, and there are videos on my channel about rotations and translations and that sort of stuff, so please do have a look at that. Okay, so describe fully the single transformation. Well, it's going to be a rotation, and it's going to be a rotation of 90 degrees, and it's anti-clockwise. No, it's not, it's clockwise P onto R, isn't it? Yes, beg your pardon. It's clockwise. Okay, and it's around point minus 1, 1. Okay, and that would be absolutely fine for this particular question. However, please do check that using tracing paper if you wanted to, and also download the videos on the 3-Minute Maths website, and you'll be able to have a go at each of these. Okay, so let's have a look then at question number 9, and it says Martin truncates the number n to 1 digit. The result is 7. Write down the error interval. Okay, oh my gosh. So the short answer to this is that n is greater than or equal to 7. So in other words, n could be 7. It could be. Okay, or it could be 7.1, 7.2, something like that. However, to truncate, in other words, get the result of one single digit, it has to be less than 8. Okay, bit of a difficult one really conceptually, and I know that might confuse a few people, but basically that's what they mean by the error interval. So what I will do is post some videos on that particular topic at some point in the future. I will make a note of it and have a go at that. Okay, let's move on then to question number 10. And question number 10 is going to be about mixing paint. It seems this particular paper has got paint in it, or paint on the brain, after we did painting a trapezium a little bit earlier on in the previous video. Okay, so Robert makes 50 litres of green paint by mixing yellow and blue in the ratio of 2 to 3. So basically we've got yellow and blue in the ratio of 2 to 3. Okay, that's fine. So remember that he's mixing 50 litres, okay? So at the moment, this would be 5 litres, okay? 3 litres of blue, 2 litres of yellow is going to give you 5 litres of paint, okay? But he's got 50 litres, okay? So if he wants 50 litres, okay, and bearing in mind, again, I haven't read the whole question, but pound to a penny, that is going to be useful to me because I do know that they want 50 litres, so therefore he's going to use 20 litres of yellow and 30 litres of blue. Okay, then it says yellow paint is sold in 5 litre tins. Well, if that is the case, then he needs 4 of them. So 4 tins. Okay, and each tin of paint costs £26, so therefore he's going to spend £104. Okay, so hopefully we can do exactly the same exercise now with the blue paint, because he's going to need 3 tins of blue paint. Okay, and each tin of blue paint costs £48, so therefore he's going to spend £144. Okay, so if he was doing this, he's going to spend £248 in total cost. Okay, hopefully that's all right for you. All right, let's have a look at the rest of the question. Okay, so Robert sells all the green paint he makes in 10 litre tins. He sells each tin of green paint for £66.96. Work out Robert's percentage profit. Well, he's going to make 50 litres of green paint. If he sells it in 10 litre tins, then basically, and he sells all 5 of them, then he's going to make going to make 50 litres, 10 litre tins, so he's going to sell 5 litres, 5 tins of them. So in this sale, okay, he sells each tin paint for £66.96. He needs to sell 5 tins of paint, okay, because each tin of paint, green paint, has got 10 litres in it, okay. Phew, I'm glad we got there eventually. So therefore, his gross sales, if you like, is going to be £334.80p, okay, total. So in other words, what we've got now is this is his, if you like, his gross total. Okay, that's how much money he actually gains, and this is his net total. So this is how much money he actually spent. Okay, so let's have a look now at working out his percentage profit. So the profit is always going to be the difference divided by the original. So percentage profit is equal to difference over original. Remember, that's the fraction, so I need to multiply that by 100 to actually get my percentage. So the difference is going to be the difference between the total he sells for, which is £334.80, minus the total he bought for, which is £248, divided by his original, which is £248. Okay, so hopefully that's all right. Again, if you go to the channel, there are some playlists and some more videos on working with percentage profit. Okay, so if I pop that into a calculator, multiply it by 100, what I'm actually going to get is 35, which is 35%, and that's the answer to this particular question. Okay, hopefully that's been all right for you. Sorry about that little deviation right halfway through. I couldn't quite figure out what I'd done there, but yeah, we got there in the end. Okay, so let's move on then to question number 11. We're about 15 minutes into the video, so we'll do another 10 minutes or so and see how far we get with it. Okay, so let's have a look then at question number 11, which is a counting strategies type video. Now, I've just posted counting strategies actually on the channel, so please do have a look at it. Okay, so Janet is going to choose one of the following combinations for her meal. Okay, a starter and a main or a dessert, starter, a main or a dessert. Okay, all right, I wouldn't want to go to dinner with Janet. Okay, not really. Okay, so let's have a look at her combinations for starter and main. Okay, so for starter and main, well, there's 9 starter dishes and 15 main dishes. So if I multiply those together, she's got a choice of 135 different combinations. Okay, if he chooses one of each. Okay, or her other option, okay, is going to be a main and a dessert. Okay, or main times dessert. So the main dish is 15 combinations, and the desserts there's going to be 8 combinations, so that's going to give us 120. Okay, or if she's feeling particularly like that, our friend Janet, okay, she's going to have one from each. So she's going to have a starter, or a main, or a dessert, okay, and that's going to be a choice of 9 starters, 15 mains, or 8 desserts. Okay, multiply all that together, you get 1,080. Okay, so if you add up all of those different combinations, okay, 1335 is the total, which are the number of different ways in which Janet can choose her meal, and probably by that time I'd have left the restaurant. Okay, so let's move on. I'd go to the McDonald's possibly. Okay, let's move on to question number 12. Okay, so we've got I don't know, 4 or 5 minutes on this particular video, so let's see how we get on with it. Okay, please do stop the video, have a go at this question, compare your solutions. All right, so we've got to write this one in the format of that. Now, you just got to be a little bit careful with these types of questions, bearing in mind we are getting towards the middle of the particular paper, so things are going to get a little bit more challenging here, but please do have a go at it and see how you get on. Okay, now one of the things that kind of leaps out a little bit is 4x squared minus 9 is actually the difference of 2 squares. Okay, so you can write that as 2x plus 3 multiplied by 2x minus 3. Okay, that's exactly the same as this one, and again, if you're not sure, please do have a look at some of the other videos on the channel. Okay, so it also means that if you spotted it, the denominator of the first fraction I can factorize for 3, which means, guess what, I get 2x plus 3. Okay, so actually already I can get rid of these 2 terms or bracketed terms. Okay, so hopefully now I can do something very similar with the next one. I'm not quite sure. We'll have a look and see where we end up. Okay, let's have a look at the next one. Well, I've got multiplied by 2x on the numerator, and at the bottom I'm going to factorize for x, and I get x minus 3. Okay, so what have I got in total? Well, let's have a look. If I multiply this out, I'm going to get 2x times 2x minus 3, which is the numerator, and then the denominator I'm going to get 3x multiplied by x minus 3. Okay, so I'm in a position now where I can kind of get rid of the x values, or at least these two values here. And then if I want to put it into this form, okay, then I'm just going to multiply it out. So I get 4x minus 6 divided by 3x minus 9, and that's the answer to this particular question. Hopefully that was okay for you. So again, things are just getting a little bit tougher with these types of questions, so therefore just take your time, but do stop the video, do have a go at it. Okay, I think we'll do part B, if that's okay. Part B is a bit of a long haul, I'm afraid, so this will then take us through to the end of this particular video. Okay, now as you know, when you're adding or subtracting fractions, you need to make sure the denominators are the same. Okay, so it's going to be a bit of working out, but basically if I look at each of these denominators in turn, what I need to do is I need to multiply all of these together in order to have a common denominator for each fraction. So therefore what I'm going to do is I'm going to write 3 fractions, all of which are over x times x plus 1 multiplied by x minus 2. Okay, so that's my first one. My next one is going to be x times x plus 1 multiplied by x minus 2. Okay, and then my last one, now I've put a minus in there. So as you know, if you watch my channel on a regular basis, I'm a bit of a fan of square brackets, particularly when it comes to negative terms. So I would always put this into a square bracket, because it reminds me then that whatever happens in here is going to be affected by this negative. So you've got to be a little bit careful. Just make yourself aware of this. Okay, so I'm still going to write the same denominator in as the others, and I'm going to close my square brackets. Okay, so I now know I've got a position where I've got 3 fractions, all of which have got the same denominator. All I've got to do now is worry about the numerator. So the numerator on this one is 3. Well, it's already over x plus 1. So therefore, I'm going to multiply that by 3 times x minus 2. Now, I know there's a lot of brackets floating around, but hopefully it'll be okay. All right, let's have a look at the next fraction along, 1 over x minus 2. Okay, well, that's 1. And I've already got x minus 2, so that's okay. So it's 1 times x multiplied by x plus 1. Okay, and like a lot of these types of questions, if you're fairly methodical about it, then hopefully you'll come out with a half reasonable solution for 3 marks. Okay, last one. Well, I'm already over x, so therefore I've got 4 times x plus 1 multiplied by x minus 2. Okay, I've already got my x from that denominator already there. Okay, so now it's a case really of just sort of tidying this up a little bit. So let's multiply out the brackets and see where we end up. So I'm going to leave this 3 in place. But I've got x times x is x squared minus 2x, okay? And again, I'm going to put this over exactly the same denominator. But I think what I'll do is, because I'm adding these two together, I'm actually going to just add them together and write it down as x times x plus 1 multiplied by x minus 2. Okay, and this is going to be plus. So x times x is x squared, and then x times 1 is plus x. Remember, I don't need to take into account this 1 at the front here. It's absolutely fine. Okay, so that deals with that particular sort of addition part of it. Let's have a look at the subtraction part of it. Well, I'm going to multiply this out. I'm going to say, well, that's the same. I'm going to keep those brackets in place. It's the same as saying 4 times, and I'm going to multiply these out. X times x is x squared minus 2x plus x minus 2. Okay, and again, that's all over x times x plus 1 times x minus 2. Okay, so hopefully you're following this all right. So, right, let's just take a bit of a step, okay, and what we'll do is we'll just tidy up this little bit here, I think, because it's a bit not quite at the moment. I got minus 2x plus x. So what I'm going to do is I'm just going to scrub that out and say that's going to be minus x. Okay, it'll just save me a line when I'm actually showing my working. Okay, or in this particular video, it'll give me a little bit of extra space just to work. Okay, so let's move on then. So where we are now is I need to just start removing brackets and also dealing with this negative here. So if I look at these two fractions brought together, what I've got is going to be, actually no, I'll multiply out first. I got 3 times x squared minus 6x, which is that and that, okay, plus x squared plus x, okay, again, that's all divided by x times x plus 1 times x minus 2, okay, and this one then I'm going to get, again, square brackets is going to be 4x squared minus 4x minus 8, okay, and again, all divided by x times x plus 1 times x minus 2. Okay, this is where kind of we need to bring everything together, and this is where you've just got to maybe skip a step here or there, but hopefully we'll get there eventually. Okay, so when I now bring everything together into one denominator, I've got x times x plus 1 multiplied by x minus 2. Okay, so, right, let's have a look. I've got 3x squared plus x squared. Okay, well, that's fine. That's going to be 4x squared. Okay, I've got minus 6x plus x. Okay, well, that's fine as well, because minus 6x plus x is going to give me minus 5x. Okay, I'm happy with that. Right, let's have a look at now what happens here at the top. Now, remember that this negative, as I mentioned before, affects everything. So, minus 4x squared, okay? And then I've got minus times a minus, so that's going to give me plus 4x, okay? Be very careful with these, okay? This is what happens a lot, I'm afraid. Okay, so minus times a minus again is also plus 8. Okay, right, so it's looking a little bit tidier, but we're not quite there. We're almost there, actually. So let's have a look. 4x squared and minus 4x squared I can cancel out. And I've got minus 5x and plus 4x is going to give me minus x. So this is going to give me, if I just put a little kind of arrow there, it's going to give me minus x plus 8. Divided by x times x plus 1 multiplied by x minus 2. Okay, and that actually is the answer to the question. It's just a little bit neater to swap these two around. So I'm running out of space to write this, but I'll do my best. If I've got space on the video here, let's move this up a little bit. Okay, so if I wanted to write that just a little bit neater, I would write that as being 8 minus x divided by x times x plus 1 multiplied by x minus 2. And that actually would be the answer to the question. And if you wrote that, you've done a fantastic job. So it does get a little bit complex towards the end there, but hopefully that's been okay for you. Okay, that's 27 minutes into the video. Please do add a comment below if you're not sure about anything. I do have a playlist with some of these fractions on it, so there's plenty more practice, and please do let me know if you need any support in the comments, and I'll always come back to you. I look forward to seeing you inside the next video, where we're going to start from question number 13.